Hello everyone, I am Professor G.P. Davre from Kekewag Institute of Engineering Education and Research, Nasik. Today we will try to learn digital and computer based control system. So starting with the signals type, there are two types of signal normally, analog and digital signals. So what is analog signal? Analog signal is in the form of continuous signal that a time varying variable, which measures one quantity in terms of some other quantity. For example, the analog signal is speedometer needle as a function of the speed. So diagrammatically, the output from the analog signal is a continuous, as I told you, and which can varies with the time. So this is one can say the output of the analog signal, which is nothing but the continuous signal. Then the next important type is the digital signal. So digital signal is accept the data in the binary form, that is 0 and in the form of 1, which is not continuous, that is a discrete signal. So 1 0 1 0 either on or off in the form that it accepts the data, and this is nothing but the digital signal, because the computer can only perform or process the data in the form of digits. Yes, the computer can only accept the data in the form of digits. So this is nothing but the digital signals, which is work on the binary, which is not continuous, which is discrete. This and the diagrammatically it can be represented in this format. Now by this closed loop we can understand how the analog to digital converter we can convert, and how the analog signal can be converted into digital. This is a process where we are getting the output. Always remember, whatever the process output we will get in the form of continuous or analog signal, then the measurement of the output will take place. Now before sending it to the computer, it is very important to convert this analog or a continuous signal into digital signal. So analog to digital converter is placed just before the computer. Then after processing from this computer, we will receive the information in the form of digits or a digital signal. So it is again important to convert these digital signals to the analog signal, because the process can accept the continuous signal. So the digital to analog converter is placed just after the computer, and the signal is again converted back to the analog or continuous, and after it is sent back to the process. So again the process will take place and it will send the continuous signal. Again we will convert into digit, and after digit again we will convert it into analog. So that's how the closed loop can work with the digital computer. So earlier I have already explained the A to D converter, which is placed earlier or just before the computer, and as the computer send the data in the form of digit, so it is important to convert that into D to A converter and again send it back to the computer. So A oblique D means what? Basically A to D converter or analog to digital converter, and D oblique A means what? Basically digital to analog converter. So analog to digital converter, a device that convert analog signals into digital signal, it is called as analog to digital converter, and the device which will convert the signal to analog by digital, which is called as D to A converter. Right? So it is very important to know the elements which convert the analog signal into digital and digital into analog. So sampler what it does, basically it is a unit, or one can say the equipment, which will convert the analog or continuous signal into digital signal. So A to D. So this is where you can put the sampler. You can convert your continuous or analog signal into digital signal, and after the computer information received in the form of digital, so D to A, where you can put the hold element, where it can convert the digital signals into continuous or analog signal. Now this is one of the diagrammatic representation how the signals from ADC, that is A to D converter, can be done. So analog signal we will receive, right? Then the sampler or sampling element is placed, and as you can see these blue lines which have converted into the discrete or digital signals, and after the coding the computer can accept the data. So that's how the analog to digital conversion takes place, mainly by using these steps. So sampler and the coding mechanism will be done for accepting the data by the computer. So after the conversion, the signal in the form of discrete or digital will look like in this format. The digital system work with the discrete state. Yes, you can see with that particular time it will accept the data and it will show the data. Taking samples from each location, it will take the sample to the each location. So the data will be represented point to point in the form of binary, and it will not be continuous. Now talking about the good point and the disadvantages of this digital control system, it reduces the cost, it is very flexible in operation. The digital control system are more suitable for the modern control system. Yes, the digital computer we have to fit with the modern system. Then I have mentioned here two disadvantages, but my opinion the most important disadvantage about this digital control system is that it produces little bit time delay. It is introduce the time delay, so it in the loop. So this is a big problem about this digital control system. So yes, time delay can be observed with this digital control system. Then the one of the most important control system is the supervisory control system. So supervisory control system is what basically a computer is used to change only the set point or values of adjustable parameter of a local computer. So we will try to learn the supervisory by observing this diagram. This is a process. As you can see, the process output is sent to the controller. As you can see, the process output is sent to the controller, and one of the output is sent to the supervisory controller, where the computer can adjust the values of this controller. As you can see, according to the information received from this process, the adjustable mechanism through the supervisory control on this controller can be done. So after adjustment parameter, adjusting the values of this controller will give the output to the process, and according to that the process will work. Again the output will send back both to the controller and the supervisory element, and again the adjustment of this controller can be done. So continuously this kind of processes takes place. So basically the computer will have control on this controller, right, which will supervise the information obtained from this controller and which will adjust the parameter of this controller. So used in a chemical process to optimize the process and to maximize the functional cost and also to maximize the efficiency. Controller are analog and digital, both controllers are there. The control system gives optimum values of the set point for various controller. This is good point about the supervisory. It gives the optimum values of all the set point of various controllers. So this is one of the big advantage of the supervisory control system. Then the next important system is the distributor control system. So what is distributor control system? Three important points I will tell you, and then we'll try directly go back to the diagram, and then you will understand. Control elements are distributed throughout the system. Yes, remember the control elements are distributed throughout the system. The PLCs are incorporated with the DCS. DCS is the distributed control system, and the PLC is programmable logical controller which accept the data and send back, means it is used as a transmitter for the accepting and sending to the data. The DCS equipment is located at isolated place from the actual station of the industry. So these are very important points. The DCS element is located or at isolated place from the center of the industry. So this is one of the industrial picture. This is an operator who is seated in front of this computer and can see all the data of the process plant in the form of pressure, temperature for every equipment, and he can adjust these values by sitting in AC room and through this keypad or computer. So he can adjust the value and can observe, can have control throughout the plant. So the distributed controller can provide the information through PLCs, and this person or operator can see the data who will have good control on each and every equipment throughout overall the plant, and he can adjust the data of this temperature, pressure, flow, composition, which will displayed on this computer. The process parameter that are views, that is pressure, flow, composition, he can adjust the values and change as per the requirement. So DCS control system, the person who is far away from, one can say, the plant, the controllers are distributed in the plant. Through the PLC the information receives for the pressure, flow rate and composition and parameter. Then the person can adjust this value by sitting in a AC cabin and watching on the screen which is views in front of him, and adjust the data by using keypad and this computer. So this is a distributed control system or DCS control system. So in paper we can draw this kind of diagram. So process is there, local computer which will send you the information to the supervisory controller or computer, then the supervisory controller can take the action and again it is sending back to the process. So that's how the PLC which are located here, which will transfer the information from process to supervisory host and from supervisory computer to the process. So that's how the DCS control system is very important and playing very important role. So good points and advantages one can say about the DCS system: access a large amount of current information from the data highway. Yes, it can access large amount of data in various format, pressure, temperature, many equipment. For about many equipment it can storage the data and handle the data. Monitoring the trains of the past process condition, it saves the trains of the past condition, so it can also monitor the train of the past condition. Readily install new online measurement together with the local computer. It can have the online measurement facility, so it is very good advantageous point. Alternate quickly among the standard controller strategies and readjust the controller parameter in the software. It can have a facility of readjusting the controller parameter in the software. Then easy plant monitoring, yes, by sitting with the in front of computer or one or two computer, you can have overall plant monitoring. Chemical plants are generally very big, so their monitoring is difficult, but by using the DCS control system, we can monitor the plant with a less functional cost and also less operating cost. So the initial cost is high about the DCS control system, but once it installed, the other costs are getting minimized. So these are the very good points about the DCS control system. So thank you very much. I hope you will like my video and subscribe my video. Please like it. Thank you.